For this lesson on exponents, your Bible is going to be the table on page 330 that outlines all of the exponent rules. Now, you guys have learned most of these previously in Algebra 1. The one key rule that was excluded from the Algebra 1 CP course is the negative exponent rule. So I want to walk you through what that is and a couple examples and what to do with it when you see a negative exponent. So two variations of this rule right here. If I have a to the negative m power, what effectively happens is the numerator and denominator get switched and that negative exponent no longer becomes a negative. So if I have a to the negative m power, it becomes a to the m in a denominator, and since this expression has a invisible denominator of 1, that 1 just goes up to the numerator. There can also be a version where if I have a negative exponent in a denominator already, that effectively gets brought up to the numerator and the negative exponent is no longer negative, it will then be positive. I think the easiest way to understand this is through some examples. Also, key note that I've starred here, if you have a negative exponent, your answer is not simplified. Positive exponents only for when you simplify your answers. So let's begin with 2 right here. If I have 7 to the negative second power, what happens is you get the denominator of 1 up to the numerator and 7 to the positive second power now in the denominator. So we'll simplify this and make that 1 over 49. Let's do a very similar example right here. Pause if you want to try it yourself. So I have 3 to the negative fourth power. Let's first convert that into 1 over 3 to the fourth power and then simplify. 3 to the fourth is 81. Now, what if I'm dealing with a fraction inside parentheses? There are a couple ways you can approach these. I think for me, the first thing I would do is apply the power of a quotient rule, where first off, this exponent, negative 3, is going to get applied to both the numerator and the denominator. Now that we've gotten rid of our parentheses, let's convert this and get rid of the negative exponents. So 3 to the negative third is going to move down to the denominator. And 4 to the negative third is going to move up to the numerator. I'm going to write the final answer below right here. 4 to the third is 64, and 3 cubed is 27. Similar problem right here with variables. I would apply that quotient rule first. So let's go m to the negative fourth. So this is a combination of quotient rule and the power rule, where I have to take negative 2 and apply it to both the numerator and the denominator. When I do it to just the numerator, it's m squared and it's 2 times negative 2. So we get m to the negative fourth. When I do that for the denominator, it's going to become n to the negative 10th, right? Take n to the 5th, 5 times negative 2, n to the negative 10th. Since they both have negative exponents, we're going to flip both of them. N to the 10th is going up, m to the 4th is going down, and that's done. 2 different variables, no negative exponents, can't simplify that any further. Don't be tricked by seeing 10 and 4 there and thinking you can simplify. They're exponents on different variables. I know I've made this look a little, let's try this again. That's your m. So with different variables, I certainly can't combine or simplify those at all. 2 more examples. Let's do quotient rule first for this one down here. When I apply the negative 3 to the numerator, it's going to become positive. When I apply it to the denominator, we get s to the negative 9th. So r to the 6th in the numerator is fine. This negative exponent in the denominator is going to come up. So what we wind up getting is no longer a fraction. It's r to the 6th, s to the 9th, that's it. Denominator of 1. And then over here, a to the 3rd, b squared over a to the 5th. So I don't need to apply a negative exponent outside any parentheses. We're going to use the quotient rule here, where I have negative 3 over 5, we use the subtraction rule. When you have a quotient in between, we have a common variable here of a. We're going to do a to the negative third minus 5. So this is going to become a to the negative eighth b squared. Can't leave a negative exponent, so my final answer, b squared stays in the numerator, a to the eighth into the denominator. So hopefully these additional examples will help you, along with reviewing the exponent rules that you should mostly remember from Algebra 1.